Hey guys, welcome to the tutorial on integration. In this video, we'll talk what is integration, how to use Python to find integrals. Integrals are widely used in the areas of digital technologies like machine learning and computer vision. Integrals can be thought of inverse of derivative that we discussed in our last video. Let's take a look at a function. Suppose now we want to find the area under this function between the function line and the x-axis. The graph of this function is a straight line because f of x equals to x. Now let's say we want to find out the area of this function under two values of x. This is called the integral of the function and it is expressed like this. The integral of f of x with respect to x. To calculate this, we need to find the antiderivative of f of x, which means we need a function whose derivative is f of x. By calculating this antiderivative, we figured out that this is 1 half x squared. Now this general integral function is more useful when you want to find the specific part of the function. For example, in this case between 0 and 2, we write this like this with the lower and upper bound in the integral. We compute the formula like this. We need to apply the general integral formula to each limit and find the difference. We got our integral value as 2. Now let's see in the graph whether the area inside x from 0 to 2 is correct or not. So we can see we get two squares, each of area 1, by which we can see the integral is correct. Now let's jump into Jupyter Notebook and calculate the integral of some functions. Now we'll use our knowledge of NumPy and Matplotlib to plot few functions and show the graph beneath those functions. If you don't know about Matplotlib and NumPy, you can go to our previous video and watch those lectures. We'll create a Python lambda function in which first we'll use exponential function to plot the value of x between 0.0 to 8. We will use a fill function to fill the area between x and f of x. This will show the area of a function between different data points. We can also add a title for our plot. You can see the function plot and the shaded region, which means the area of this function. Since it's an exponential function, you can see it grows exponentially. Now we can try different functions. This is a square function, and similarly you can see the area in this function. We can also use a SymPy library to find out the integrals of different functions. Now once you run the cell, you can see the integral of these expressions. Now to build on your existing knowledge, we have also provided a lot of exercises for you to try your hands on. If you're watching this on YouTube, make sure you check out the video description for the complementing repository. This was all about integration. We'll meet next time.